Having electrical power at your fingertips when you're out in the bush is one of the best things about RV camping. Whether you're just charging a phone or running an air conditioner, you've got to have the right power setup for the job. 240 volt AC power is the dead set easiest power source for RVs. You just turn up at your caravan park site, plug in the lead, flick the power switch, and you're good to go. You've got enough 240 volt power to run everything in your RV, from lights to air conditioners. RVs are set up with 15 amp power circuits, which is fine when you're using caravan park power outlets. But what if you want to plug in at home or at the showgrounds, for example, where mains power is rated at 10 amps? There are two ways to power up or charge your RV from a domestic 10 amp supply. Get a licensed electrician to set up a 15 amp outlet at your home, or use a 10 amp to 15 amp converter such as the Amphibian. You might have noticed that your 15 amp RV power lead has a big chunky earth pin. They are designed in a way so that you can't plug into your domestic 10 amp system at home. Some people do, however, try to modify the lead so they can hook up at home. That is illegal and it's dangerous. Using a 15 amp lead with a 10 amp home circuit board can actually overload the home circuits and start a fire. The problem with running 240 volt power is you always need someone to plug in, which isn't going to happen when you're free camping. You need an alternative power source such as 12 volt onboard batteries or a generator. The heart of any 12 volt RV system is the onboard or house battery. There are two types of 12 volt battery, starting and deep cycle. A starting battery is designed to handle the big current draw needed to start a vehicle, and they need to stay above about 80% of their capacity. They're not an ideal RV battery. So what you want in your RV is a deep cycle battery. Deep cycle batteries range from the inexpensive wet cell lead acid battery to the premium lithium battery. A wet cell lead acid deep cycle battery is the cheapest option, but it isn't always suitable. A wet cell battery vents gas to the atmosphere, so it must be kept upright and in a well ventilated area. You have to keep some wet cell batteries topped up with distilled water, although some are maintenance free and they can't charge up as quickly as other deep cycle batteries. A step up from the wet cell battery is this guy here. It is the absorbed glass mat or AGM battery. While this is also a lead acid battery, it absorbs its electrolyte in the fiberglass matting and does not vent gas to the atmosphere unless it's being overcharged. An AGM battery has much lower resistance than a wet cell battery, so it charges more quickly and also performs better under heavy load conditions. Then there's the gel lead acid battery, which suspends the electrolyte in a gel paste. Like the AGM battery, the gel does not vent to the atmosphere, and so too is maintenance free. But if you want the ultimate in-house batteries, then you might want to look at one of these, and this is lithium. The beauty of lithium is that it can release energy at high levels while maintaining its voltage, and it matches perfectly to running 240 volt appliances through an inverter. But this sort of power doesn't come cheap. In fact, this box alone costs a shade under $2,000. With conventional deep cycle batteries, their voltage slowly falls as they discharge, and their available voltage also decreases as load increases. They're not good at discharging fast. Meanwhile, lithium batteries will give the peak power required and remain constant voltage even with a heavy load. In practice, that voltage is likely to be up to about 13 volts. Lithium batteries also will accept higher charge current than an AGM battery. You're not supposed to let an AGM battery drop to below about 50% of its capacity. But a lithium battery's charge lasts longer, as it will easily cope with a drop to 20%. You can't let a lithium battery run completely flat, although most quality lithium batteries will be fitted with an internal battery management system that will protect the cells in case of over discharge. Check though before you buy one. Now, like I was saying before, you don't get all this lithium battery goodness for nothing. To replace an existing lead acid battery bank with lithium batteries could initially cost you up to 2 to 3 times more, and your existing charging sources like AC battery chargers, solar regulators, alternators and DC to DC chargers may not be compatible. You need to ensure they have a lithium profile, and of course it will cost you more to replace them if they don't. AGM batteries provide the best compromise of performance, price and longevity when running RV gear such as 12-volt LED lights, water pumps, TVs and radios. But if you want to run big 240-volt gear like an air conditioner, a washing machine or microwave when you're free camping, you will want to think about lithium batteries or a generator. If you need more capacity than one battery can hold, you can hook up your AGM batteries in parallel. How many you link is determined by the size of your charger, but this setup will give you their combined amperage output while still remaining at 12 volts. The wiring should not be any longer than necessary and suitably rated to do the job. Make sure the batteries are mounted as close as possible to avoid any voltage drop. However, linking lithium batteries in parallel needs care. You must refer to your battery manufacturer requirements on this. It's all to do with what's called cell pack balancing, and it usually needs to be set up with dedicated balancing equipment. Lithium batteries with inbuilt battery management take care of the cell balancing and can normally be joined in parallel to create a larger battery bank. Linking lithium batteries without these management systems can cause problems, as the lowest resistance battery in the pack will do all the work. It's possible you might be better off getting a higher capacity single battery pack to run your high current draw charge gear, or look for a battery pack system that will meet those requirements. So where should you actually mount those house batteries in your RV? Well, keep in mind that an AGM deep cycle battery is pretty heavy. They can be up to 30 kilos. So you want to mount them forward of the axle and nice and low in your RV. Lithium batteries, they are often around about half the weight of an AGM battery, but you still want to mount them forward and nice and low. But you can go too far forward. Some people look at this beautiful long drawbar and they think, well, I might throw my battery in a battery box out the front there. That's nice and forward and low, but that's going to be too far forward and it's going to adversely affect the bore weight of your RV. Running 12-volt equipment is a no-brainer with 12-volt batteries, but what about 240-volt AC gear? You need an inverter, one of these things, which changes 12-volt DC input to 240-volt AC output. There are a few different types of inverters: modified sine wave and pure sine wave. Out of these, it's the pure sine wave inverter you want for a 12-volt RV power setup. Pure sine wave inverters smooth out any voltage spikes and can run sensitive electronic gear like laptops without damaging them. Pure sine wave inverters have the same output as your 240-volt socket at home, so equipment will also run more efficiently. Unless you're only free camping for a couple of days at a time, those U-Butte house batteries are going to need to be charged up. At the most basic level, a 240-volt to 12-volt charger is the way to go. As a rule of thumb, for a 100 amp hour battery, a 25 amp charger should be fine. Or for 2 or more batteries, go for a 40 amp charger. Just be aware that you can't dust off your old charger you bought 20 years ago and use it with AGM or lithium batteries. Each one needs a specific charge profile and they must be wired up as close as possible to the house batteries to avoid voltage drop. Using such a charger is fine if you have 240 volt mains power or a generator handy, but if you don't, you still have a couple of good charging options. One way to charge your house batteries is using your tow vehicle's alternator. With the engine running, the alternator provides power to run through a DC to DC charger in the RV and then to the house battery. Most newer vehicles have what's called a smart alternator system, which allows the vehicle to control the output voltage from the alternator based on vehicle operating conditions to reduce electrical load. This type of alternator doesn't do a great job of charging a house battery due to the varying voltage of the alternator. This type of alternator doesn't do a great job of charging a house battery due to the varying voltage of the alternator. To get around this, you'll need one of these, a DC to DC charger. A good DC to DC charger will fully charge the RV's house battery whether the vehicle has an old school fixed voltage alternator or a newer smart alternator. A good DC to DC charger will draw current from the alternator and bring a discharged house battery up to 100% using battery specific 3-stage charge profiles. The DC to DC charger should be mounted as close as possible to the house battery to avoid voltage drop. To charge a Caravan's house battery from a vehicle's alternator, you need to run a minimum of 6mm squared cable and also use a 50 amp Anderson plug to connect the wires at the tow bar. If you don't, you'll have too much voltage drop, which will reduce the amount of charge going into your house battery. You'll need a good quality inline MIDI fuse or a resettable circuit breaker, and it is a good idea to fit a relay so that the plug is only powered when the vehicle is switched on. That's so if you leave the Caravan accessories like a fridge on and forget to unplug the vehicle overnight, for example, you won't run the vehicle battery flat. Although a good DC to DC charger will actually isolate the vehicle and house batteries. Now, the El Cheapo way of making power at camp is to kick your car over and make your alternator charge your system up. But that burns fuel and it also makes noise, and it could also make for a pretty uncomfortable camping experience as you pee off your neighbours. For years, a portable generator has been the go-to 240 volt power source when it comes to bush camping. Generators come with different output ratings, so choosing the one you need depends on how you use it. Jennies are rated in kilovolt amps, but you want to convert that into watts to figure out what equipment the Jenny will comfortably power. Electrical gear draws a certain amount of power, but rarely consumes all the power they draw. The difference is known as the power factor. Getting the exact power factor for each appliance is difficult, so as a rule of thumb, let's assume a power factor of 0.8 for all electrical loads. So in this case, a 2 kVA Jenny spits out about 1600 watts. The catch is that a generator's quoted power is for its peak rating, which it can only sustain for a short time. You have to dig out its continuous rating specification, which is usually about 80% of its peak rating. A small generator like this one can also run low current draw items like a small fridge, TV and RV lights. If you want to run a 240 volt air conditioner or a big 240 volt fridge at camp, it gets a bit tricky. When an electrical motor powers up, it can draw a lot more current than it needs once running. So for example, a 1400 watt air conditioner may need up to 4800 watts to start it. The best aircon units have what's called a soft start, which basically lowers the amount of power needed to get the motor spinning. In any case, a 2.4 kVA generator like this one should run an air conditioner, no worries, in all sorts of temperatures. Whatever Jenny you choose, make sure it's the sine wave inverter type. These generators filter the output to deliver smooth power that won't damage delicate electronics. Just like using your vehicle alternator to charge up house batteries, a generator makes noise, although modern ones like this one are really quiet. When you're using them in a camp situation, try and position the generator as close as possible to your campsite so that you're not actually affecting other campers. Likewise, you can run one lead to get it right away from everyone's camp. Of course, it's worth remembering that Jennies need fuel and maintenance and add at least 20 kilos to your RV's payload, including fuel. Generators are mostly permitted for use in national parks, but with restrictions. It's best to check with your national park before you go. There's one bit of gear that'll cost you nothing more to run than a little bit of free sunshine, and that of course is solar panels. There are 3 different types of cells that you can choose from. There's amorphous, monocrystalline and polycrystalline. Polycrystalline are less efficient than monocrystalline cells and need more surface area for the same output. Both types need to be as perpendicular to the sun as possible for best performance. Amorphous panels have the most efficient solar cell, although they do require twice as much surface area for the same power output as a monocrystalline blanket or panel. They are more flexible though and can handle higher temperatures better without output being affected. Amorphous cells are constructed from a fine layer of silicon, which makes the solar panels more flexible and lighter. Amorphous cells also perform better in low light conditions compared to crystalline cells. So how much solar do you actually need to keep batteries charged when free camping? There are many variables such as how much power you draw and how much sun the panels actually get to produce charge, but a rough rule of thumb is about 250 watts of nominal 12 volt solar panels can belt approximately 50 amp hours back into the house battery each day. Solar calculators, like this one from Red Arc's website, are also a handy way of calculating your solar needs. Solar panels require a regulator so that the voltage going into the battery is consistent. A maximum power point tracking solar regulator is the smartest type because it will find the best point at which the panels will achieve the maximum power from the cell to ensure you get the most power possible from your solar panels at any point in time. So how do you work out which 12-volt battery system and which charging method is best for you? For starters, you need to whip out the calculator and do some sums to see what gear you typically use and how much power it sucks up. For example, you have 6 LED downlights in your van, each one rated at 3.5 watts. First, multiply the number of lights you have by the rated watts per light. Then divide by 12 volts to get the amps, the light draw. Then multiply this by the number of hours you'll run them. Let's say 4 hours. In this example, you're pulling a total of 7 amp hours out of the battery a day. Then you've got your 60-watt compressor fridge. That fridge will use 5 amps per hour, but only when the compressor is running. To give you a rough example, so the compressor runs about 15% of the time and you have 0.75 amps. Multiply that by 24 hours and you have 18 amp hours. With just these two basic camping requirements, you're using 25 amp hours a day. With a 100 amp hour AGM battery, you'll get 2 days use out of it before it's dropped to its safe state of minimum charge and needs to be recharged. Remember, you don't want to completely drain your AGM battery because this will reduce its lifespan. So as you've seen, there's a fair bit to get your head around to set up a spot-on RV power system. Do your homework, buy the best gear within your budget, and also be realistic about how much electrical power you really need to use. Then all that's left to do is enjoy your next bush camp with plenty of power on tap.